Hello everyone.
Hello, sir.
Okay, I started recording, so I will start explaining the calculation as well. And I will take attendance at the end of the lecture. Okay, let me share my screen. Okay, so here we have a data sheet from previous semester. Okay, so as you can see, we take reading with respect to time. So here time is in second. We took reading. So if I check how much is this by dividing to 3,600, so this is 24 hour, okay? So we have many readings. We have the diameter of the sample, height of the sample, and when the test is finished, we have weight of the soil and the ring, the mass of the empty ring and the dry soil and the ring itself, okay? Can you see my screen, by the way?
Yes.
Yes,
Can you
yes,
see
we can
also
see it.
the PowerPoint?
Yes,
Okay, so here, first of all, first thing we need to do is to find the water content of the sample in order to evaluate the final void ratio. So I will find the water content. So we know that the water content is mass of the water. So I will subtract the mass of wet soil from dry soil, and the rings will cancel each other, okay? Divided by mass of dry soil. Okay. So I got my water content, and we know that the final void ratio is the water content times the specific gravity. Okay. Now I need to find initial void ratio. So for the initial void ratio, first we know that delta E, it is not even like this. Usually it starts like this. So the equation in your textbook is, let me modify it quickly. So this is my derivation. Your equation is like this. Okay. So I basically exchange these two. Then here we can see E0. E0 is E final plus change in void ratio. Okay. Then I took change in void ratio divided by H to the other side over here. So it becomes like this. And here we have only one EF. Okay. Then here I took delta E as common factor and I subtract the remaining. So we have delta H and H0, so I make a common denominator. Okay. Then I multiply this, the invert of this on the other side, and we get delta E with respect to this. And since delta E is E0 minus E final, I took E final to the other side and we get it like this. So I will use this formula because it doesn't require calculator, okay? So let us check this formula, what it needs. So it needs initial height of the sample, we have it, which is this one. It needs the final change in height, which is last reading. Okay, so delta H is the final reading in the table. Okay, so this is in division. So let us find delta H in millimeter. So delta H in millimeter is equal to the division times the conversion factor. You see here the conversion factor 0.002. Okay, so now I can use this formula to find E0, E naught. So E0 will be 1 plus E final divided by H0, which is the height of the specimen, minus delta H times delta H plus E final. Okay. Any questions so far? Okay, let us continue then. So now I finish this part of the calculation. Now I need to make this table. So on the table we will have the load in kgs. We need to have the pressure. Okay. And the change in height in millimeter, and change in void ratio and void ratio. So let us make this table. So to convert the pressure, we will use this formula: load times 9.8 times 11.04, which is the moment arm, divided by the area, times 1000 to make it in kVA, because it will be in megapascal. So first I will take the load in kgs, and I will base them here. I will make my table over here. Oh, sorry. Okay, so this is loads in kgs. So pressure will be, it is, as we say, load times the gravity, 9.81, times the moment arm correction factor, times 1000, divided by the area, which is the diameter square. So I will fix this. Then I will put square divided by 4 times pi. Okay. Then I will click and drag. So here we have the pressures evaluated. Now I need to find change in height in millimeters. So first I will get the change in height in division. So I will go to last row, copy the cells, paste them here. So first dial at 0, it is 0. So this is delta H in division. Okay. Then I need to find delta H in millimeter. So it is the division times 0.002. Click and drag. We get the change in height. Then I will check the formula for delta E. So delta E is 1 plus E0 divided by H0 times delta H. So let me copy this.
Sorry, sir.
Yes.
To find the division, so we don't need to multiply it by 2.54.
No, I multiply it, look, 0.002 for every cell. The division, you take it as it is. It is what we read from the dial gauge. So dial gauge gave us division, but we want millimeter. So when we want to make it to millimeter, like here, we multiply with 0.002. Because look here, the conversion factor, every one division is 0.002 millimeter, okay?
Okay. Thank you.
Okay, so now I think I lost the equation. I will copy it, paste it, not like this. I will paste it here, okay. So, as we can see, change in E, delta E. I don't know if I can copy this here, so we have the same symbols, okay. So, as you can see, we need the initial void ratio, which is over there. We already found it here, right? So, it will be 1 plus E0. Okay, you fix it by clicking F4. Okay, when I click F4, it add the dollar sign before the letter and after the letter. By this, it will be locked. Okay. Then divided by H0, which is this one. Again, I lock it. As you can see, there is dollar signs before and after. Times change in height, which is this one. So click and drag. We get the change in void ratio. Check if these cells are locked. It is okay. Right? You see, they didn't move. Now I can find E. Let me just reduce the font of this one. Okay, so now E is, again, I will go check the formula. So E is E zeros. E is E0. This E0, so I will fix it minus change in E. Okay. Click and drag. So when you drag, this number should be your final void ratio if you've done everything correctly. Let us check this and this. As you can see, they are indeed equal. So our calculation is okay. Okay, now we need to plot our curve. So select all the value except the zeros. Select all the value and select all the value corresponding. Then go insert, scatter, and select this one. Scatter with the smooth lines and markers, okay? Then right click on the x-axis, make it logarithmic scale, and we get our curve. Okay, I will change the setup of the curve. So maybe this is, I will make it start from 0.4 and end at 1.5. Or maybe 0.6 it starts. So yes. So this will be our curve. Any question so far? So this is stress KBA and this is...
What do you mean by the dollar sign?
Yes, what I mean by the dollar signs. Okay, so here, as you can see, in this calculation, let me get the equation back. You see in this equation, I have E0, okay? Right, which is only there.
Yeah.
I have E0 in one cell. So see if I remove the dollar signs, okay? Let us remove the dollar sign. Because I wrote the equation only once, I wrote it here and I click and drag. See what happened when I remove the dollar signs. Because when I remove it, as you see, it shifts downward, right? For every cell you go down, it will shift with it. It go down. It is the way they program Excel. Look, these red and blue cell, they are shifting down. Understood?
Yes, I got it, sir.
So when we put the dollar signs, it prevents this from happening. Look, now if I click and drag, now the purple cell, it is shifting because we want it to shift. It is changing H, but E0 and H0, they are not shifting. They are fixed. Okay.
I got it, sir. Thank you.
Yes, so this will be our curve. So here we have the final void ratio. So this is a void ratio, sorry, and we have effective stress. Effective stress in kPa. Any questions so far about this? Very easy, I believe.
Sorry.
Yes.
The graph should be in logarithmic.
Yes, it should be in logarithmic because look, if it is not in logarithmic, it is not what you have learned. Look.
Okay.
It is very different. So here in logarithmic scale, actually this data set, it is almost perfect. You can clearly see the inflection point here. Okay. So now we need to find the calculation, the CR, which is the slope, and CC, the other slope. You can see my mouse cursor, by the way.
Yes.
Yes, okay, good. And we need to find the pre-consolidation pressure. So first of all, CR is the slope of this line, okay? So it is very easy to find. So let us take these lines. So let us say we can find it easily in Excel, so I will show you how. So here we have this point, which is the unloading. So I will take them. Here are my unloading points, okay? This is the load, the pressure, and this is the void ratio corresponding. Okay, but we need to find the log of the pressure. Log pressure. So just type log and select the number. Okay, so now if I plot these data in a scatter plot like this, okay, and I right click, add the trend line and display equation. So this value over here without the minus, it is the CR, okay? Or you may do this even without finding the log, just plotting this value. So again, insert like that. Then add a trend line, but instead of linear, select logarithmic and display equation. So it is the slope of the line, okay? But it is better to find the slope. Sorry, I removed this one. Anyway, it is gone. It is better to find with log, okay? Log pressure. Or you can find it from the curve, okay? Also for CC, you can do same. So if you use this value, let us check the values. The formula, it is a change in void ratio, right? So I will select any 2 points, this minus this. let me not confuse you a lot with Excel. Don't do this approach. So let us just do it manually. So CR will be, let me show you the formula. I think we didn't put the formula for CR. Yes. So CR or CC, it is E0 divided by this log, okay? So let me put it here, okay? So CR equal to E0. So I will select the equal to E0. So I will select
We can
this
choose any
one.
point, right?
Yes, any 2 point on the unloading part, or you can draw best fit, but it is like almost linear, okay? It will not make difference. Divided by log of the stress. Okay. So look, CR is 0.05. So let us try now with the curve, how much we will get. So I will take these pressures, the best fit line. Okay. Then draw your scatter plot. Add a trend line, then make it logarithmic, display equation, and you can see here it is incorrect, okay? Because it is using ln, so you must do, we must take the log of these values. So log these values. For some reason it is a name. 1 second, I will do it in another place. So log these values. Okay, then select the points. So this is will be my x. As you can see, we got 0.0521. When I select value from table, it is 0.059. Okay, so you can do either both approaches. Understood? Is it clear?
Yes.
Yes,
So
yes.
in the report, we should do them both or one
No,
of them?
this is for you. You do only one, okay? So it is the slope of the line. You present me only one, okay? But make sure you make them in logarithmic, okay? So this is log pressure. And this is E. This is pressure. This is my X axis. This is my Y axis, okay? Here, void ratio, as you can see here, log pressure. Similarly, for the CC, let us draw again. I think I delete the main plot. For the CC, let us check where is our version compression. We can see that from 32 up to 220. So up to 4 kilo, from 32 up to 4 kilo, it is CC. So again, I can do same thing. Take these, paste them, take the pressure. So paste it here, then let me just change the data so it is easier for me. So we can see that CC is 0.4125, or if I want to do it manually, let me change it manually and see what we will get. So 16 I will select and 32. So 37, this is because only we use not the best fit. This is with the best fit. I will accept both, okay? they are close, 0.37 and 0.412. So you can use both. Okay? Or the maximum value. It is the correct one.
Same equation for the CC. Yani
Yes,
CR and CC is same equation, yeah?
the same equation, only you reverse the pressure here. Okay, so because the stress one, always the pressure, the bigger one, you put it on top. Okay. And the
Okay.
void ratio, the bigger you put it before. So you get positive answer. Because look here, the computer, because it doesn't do this, it gives us negative always. But it doesn't matter. It is the same concept. It is the slope of the virgin compression line. And CR is the slope of the other line. Okay? Is it clear?
Yes, it's clear.
Actually,
Thank you.
even without plotting, there is a command. So let us write here CR. Linear. What was it? I forgot it, but you can find the slope. I forgot the command, but you can find the slope even with that command. It do the best fit. Anyway, so let us continue because we still have many things to discuss. So I will continue using the slides. So also you need to find the pre-consolidation pressure. So here we have our curve. You need to find the maximum point of curvature, which is very clear. Then you will draw a horizontal line like this. Then you will draw a tangent line to that point. Then you will draw a bisector line. Bisector line, it means that the angle here is same as the angle here, okay? Then you will extend the line of linear virgin compression, which is the CC line. And the point of interaction of the two blue lines, the dashed and the virgin compression line, these two, will give us the pre-consolidation pressure, okay? I think you know this, you have taken it in course.
Yes.
Is it clear?
Yeah, it's clear.
Okay, now we need to do T50, T90s to find the coefficient of hydraulic permeability and coefficient of consolidation. Okay? So as you can see here, we have many datas already in this data sheet that we didn't use. Why we took it then? So first of all, I will erase the things we have done already because it is irrelevant for the next part. Okay, so first of all, you will convert the time to, you can keep it into second, it's okay, into minute, but I wanted to convert it. So the time, I will divide it by 60. So it will be in minute. Okay, click and drag till the end. It's okay. Then I need all the loads in millimeters. So I will just do this times 0.002. Click and drag. And we will do it only for loading part. Yes, up to here. So only loading part. Here we have the loads correspond. So now one by one, I will plot the data like this, or without data point. You can do both. So insert, you can select smooth line because we have many. Then format axis, logarithmic. It will give us error because we select the 0. So do not select the 0. It is okay. And then I will do format axis, make it in reverse order. So we will have the curve like this. And I will shift this to 0.01. So I will click on this one, this axis, then select axis value, make it 0.01, so it is on the side. Okay, so now we can work with this. So here I have time is in minutes, right? And here I have delta H. Okay, understood? You need to do figure for every load. So this is for second load, for third load. Anyway, you can adjust also the scale here, so always you can see the, so this is 1. Okay, so always adjust the scale so you can see it clearly. Yes.
So how you can duplicate the figure by the
You copy it, then you paste it, then you change the y-axis like this, very easy. Copy, paste, change y-axis. So you save time. Okay. Anyway, you do like this. Okay, so now let us check what we will do with these figures. Here we have T50. Okay, it is similar but less of concavity, not like the one I showed. So first of all, you come to 4 minutes over here, as you can see, and you draw a horizontal line. Then you come to 1 minute and you draw another horizontal line. You measure this distance. Okay. You measure this distance and you took it and you put it on top of the 1 minute line. Okay. So same distance, this and this, they are equal. This is to find what we call U0. Then you come to the end of the curve and you draw a tangent line. And here there is a line as well. You draw another line, okay? Here we call it U100. You take U0, you add it to U100 and you divide it by 2, you find U50. You take U50, you intersect with your line. Then you go upward, you read the value. So this will be T50. Here it is like 4, 5, 6 point something. 6 point something minute, okay? Then you use this formula CV equals 0.197 D squared over T50. What is D squared? D squared is the height of the specimen minus this value, okay, minus the U50 divided by 2. So D, let me write it here, D squared D equal H0, okay, minus U50, okay, and all this divided by 2. Okay, and this is a square, so you square it up. Why we divide by 2? If you remember when we did the experiment, we had porous stone on top, porous stone on the bottom. So we create what we call two-way drainage. Okay. So I need to see these lines in your reports for one graph, okay? Obviously, to do the calculation, you need to do all the graphs. But for one graph, I need to see these lines that you've done it. And to add these minors, as you can see over there, I had some minor grid line. Let me extend this. So you just right click on the x-axis and you click add minor. So you see where is the 4 is. So 1, 2, you can see the minor. Now they are visible. You can change their colors. So you see them better. Okay. So I want you to draw these lines to see your calculation. Okay, method more important than the answer for me. Understood?
Yes.
Any question about T50? Okay, so now we will do the T90 method. So T90 method, it is basically same, but instead of time, we use root time. Root time, square root of time, okay? So square root, you SQRT you use and you select. So the graph will be a little bit different. So I will do like this. Again, we will not select the 0. 0 is always unknown in this. So I will plot my curve without points. Then right click, format axis. We need to make it in inverse order, and that's all. So here our axis is root time, and the y-axis is change in height, or delta H. Here. So this is how we get the curve. Now let us see what we will do the calculation. So first of all, we will extend the initial line of the curve. So initially it is linear, so we will extend it. So it touches the y-axis at 0, and it touches at x-axis. So it touches the x-axis, as we can see, at the value of 5. I will multiply this value by 1.15. Okay, x1 times 1.15. We get 5.75. So I will draw another line from the x-axis 5.75 and to the initial point that we got from the blue line. Okay. Then the intersection of the green line with the actual data set is our root time. So this is root T90 is 1.5 in this case. Then you use the formula. Okay. So again here D is same. So D is same, but here we use U90. Okay. U90 is here wherever it touch. So in this case it is 0.
What is edge 0 on this?
What?
The height edge 0. What is it?
H0 is the height of the sample. Here in this example, it is 14.
Okay, it's given.
Okay, so we remove the compression from the sample and we divide it. D stand, by the way, for drainage path, the longest path that water can take to exit the specimen. So it is the height divided by 2 because we have porous stone on top and bottom. So the largest path is the height divided by 2, and when we compress the specimen, the drainage path also reduce. Okay, this is we find the root T90 and we find CV. So you need to do this for every load again. As you can see, from T90 we get CV, and from T50 we get another CV. So in theory, they need to be identical. They need to be similar, but because they are empirical methods and they depend on your judgment, they might yield different answers. Okay? So don't worry if they are different. It is completely normal. But these both methods give you the same thing. So CV that you got from T50 is same as, it should be same as CV that you got from T90. So don't worry about that. And finally, if you have CV, you can find hydraulic conductivity by multiplying CV with MV and unit weight of water. What is MV? MV is this formula. So for every load, you need to find MV, okay? Where is our pressure? Oh, we deleted. For every load, you need to find MV. Okay, so for load 0.25, our stress 0 is 0. Second stress is the 0.25. You understood this is here, E0 is for the point, not the initial void ratio. Like if I am finding EV for this load, so E0 is that one, okay? E1 is this one. So just these 2 points, it is like CC and CR. As you can see here, we have E0, E1, 1. Understood? Don't confuse. Any question?
Yes. Can you show us how to plot the T90? T90 graph.
I show you how to plot. This is the T90. This is the plot. I show it. You can watch the recording if you missed it. So again, you will do copies of this one for every load. Okay.
4K and MB, we should find it for all the loads, or we can find it for one point and say this is K.
No, you will find it for all the points, and you will find it 2 times. One using the CV you obtain from T50. Once using the CV you obtain from T90. Okay. And at the end,
values.
and at the end you will plot changing K with respect to void ratio. So every void ratio and the K of it. Okay.
Okay.
Any questions? If there is no questions, I will take the attendance. So I will take the attendance automatically. Download attendance list. Okay, so you may hang and leave the meeting. I will stop recording as well.
Thank you.
Okay.